Hello, I'm Chris Alvarez and welcome to Spacewalk's Money Talks, where we talk about the policy, business, and technology behind space exploration and commercialization. We're on the web at spacewalksmoneytalks.com. Thank you for listening. I'm here with Professor Lembeck and Professor Putnam of University of Illinois. Thank you for speaking with me.
It's our pleasure. Yeah.
So first, space commercialization and exploration covers many fields of studies. Which of your programs or initiatives would you like to showcase today?
It's a very timely day to do that, given the first launch of the Boeing Commercial Crew Vehicle today. Commercialization is sort of a new process by which the government can get new programs started efficiently and in a cost-effective fashion. And as such, it's going to affect the broad gamut of space programs that are either ongoing in Earth orbit or exploration programs or what have you. To that extent, our educational programs here will supply students that are job ready for any of those programs.
I guess, yeah, if we had to pick a program, it'd be the Aerospace Engineering program here at the University of Illinois, and the various subsets of that graduate program and the undergraduate program, the Department of Aerospace.
So I assume entry into any of your programs is competitive. Apart from raw scores, what sorts of experience or skills would help a student stand out when being considered for admission?
Well, there's sort of two different types there. One is admission to the undergraduate program, and I'm actually not sure how much insight I can really provide into that. That's done at the university level.
Okay, that's fine.
Certain papers and things like that are important, as well as extracurriculars and a student's history and their ability to do a little bit more than just get good grades. You need more than, to get into the university. At the graduate level, we control admissions in the department, so that I can talk a little bit more about. Certainly, I think we look for very good academic performance. We get a lot of top applicants here. But I think beyond that, most of us, particularly if you're, looking for a graduate student to do research work, but we're really interested in them having some experience beyond just solving homework problems. Especially experience in a research lab, whether on their respective campus or as part of an internship. The ability to, what I look for personally is their ability to work independently and solve open-ended problems. And we try to teach those things in the undergraduate curriculum here, and I know my colleagues do at other universities, but it's hard to teach in the classroom. Right? There's really no substitute for working on sort of, quote, real-world problems in industry or as part of a research program, and that's what I personally look for the most.
Yeah. Zach mentioned the undergraduate program is being handled elsewhere, but I can see in the students that do come in the door, those that have experience in robotics, a good math and science background, those are the ones that excel when they get here because they've already had some hands-on STEM experience at the grade school or high school level.
So if you think about a student who's, finished undergrad and has their degree and, they want to go into graduate school in these fields, do you see, is it more about doing maybe unpaid internships or getting an actual job that you're at for a few years and then going into the graduate program? What do you think is the best path or a good path to take?
We see both.
Yeah, I'd say there's definitely no one path. We have all manner of graduate students in this department. We have an online program, so we have people who are practicing professionals working on master's degrees in spare time. We have, most of our graduate students are here in residence. I think we're lucky in engineering in that unpaid internships are pretty rare. Usually they're paid. I don't actually know too many students who do unpaid ones.
And by the time our seniors come to our design courses, they may have had 2 or 3 internships over the summer with a company. So it's really good experience for them.
Yeah, our students are very good, as well as, and I think there's supporting programs here at the university to aid them too in the career office and things like that. Are very good at getting internships. I think it's, particularly in engineering, it's recognized that that's an important thing, that we are, in a sense, you are getting a a university education, but we're also training you for a very specific profession. And it's, I think, exceedingly valuable to students to get out there to learn sort of how things are done in industry or in government, research labs, things like that. But also get a feel for what they want to do. You know, do they like working at a small company? Do they want to work at a big defense contractor? Do they want to work in a government lab or be a civil servant?
Do they want hands-on or more analytical computers-based stuff?
What do you see as far as the interest in private companies versus working for the government? Or
It's a mix. I think recently the balance has definitely shifted towards private companies. And this is my opinion. I don't know what, but especially some of the new space, although it's not as new as it used to be.
Right.
Just because, you know, those places are doing really exciting things. The students hear about those things, they're inspired, they want to go do it. And I think some of these newer companies have inspired some of the older companies to also do stuff like that. And that's, quite frankly, there's enough excitement about that that it's, you know, fewer people are signing up for graduate school and more of them are going straight to industry. And we see that trend generally when industry is good and exciting, students want to go straight there. And when it's a little slower, they tend to be more interested in graduate school.
Have you come across any interesting experiences or, I don't know, projects or anything that some students have done that you'd like to see more students jump into? Anything new and exciting, you know, that's out there?
Well, I know some of our students have worked on commercial cargo and commercial crew vehicles at SpaceX. We have some folks that have now working at Blue Origin. So they're getting a lot of experience in kind of a new way of thinking, a new way of doing business. They'll have those opportunities are great, and for our students to go out and make an impact immediately, it certainly is good for our department in particular to be recognized for producing students that can go out and have an immediate impact in their jobs.
Okay.
On mine, I've personally had more than one graduate student, you know, go somewhere for the summer to NASA or elsewhere, start working on a new project just because that's what they wanted to work on, and had that project actually turn into their thesis.
Okay.
And that's a great setup right there. They're working with real industry or government folks on problems that are important enough that, you know, someone in those organizations has put money behind them, in addition to getting their degree at the same time.
I think another example, I have a freshman who's in one of my design courses working on cubesats. She just came out of an internship last summer in high school with Lincoln Labs, and she built a radar. So here's a freshman in her first semester. She's working on one of our CubeSat radios and working in that development. So it's really a great experience for her to be able to step into something like that just fresh out of high school.
Yeah, definitely. What other graduate, undergraduate, or pre-college school programs have you partnered with recently on projects, if you have?
Oh, you want to go down the list?
Yeah, we have quite a number that we've worked with. I can get started in the CubeSat area. We build the CubeSat buses here at Illinois. We do all the design, development, testing here. Very little parts bought off the shelf. And so consequently, other principal investigators from across the country have come to work with us, supplying payloads. Virginia Tech, Greg Earl there has worked with a atmospheric sounding experiment called PLACE that we hope to launch later next year. We have a CubeSat that's flying a freeze-thaw experiment from Northwestern that will also fly probably in early 2021. We have actually, Zach, you probably want to talk about SASE.
Oh yeah, we had a high-altitude atmospheric probe CubeSat, which launched in April, and we worked with a co-investigator at Purdue University, doing non-equilibrium flow chemistry as you zip through the upper atmosphere at Mach 30. You know, box this big.
We've worked with Bradley University in Peoria. They developed a lot of ground operations software for us on a cooperative venture that will be supporting our CubeSats as they launch next year. We're currently working with Fermilab and the Adler Planetarium on some new ventures that we hope to take to proposal and land later on this year or next year. 4-H.
Yeah, there's a newer project seems small, but a newer program maybe we're working with 4-H in the state of Illinois to build very small cubesats, little ones that such that those can be accessible to high school students all across the state. Did I hit that right?
Yeah, that's exactly.
And on the research side, sort of independent of the CubeSat lab, we have a lot of interaction on that side. I personally have done other space-oriented projects with faculty at Purdue University and University of Colorado Boulder. So I think that kind of collaboration across institutions is pretty common.
Mm-hmm. So I sounds like you kind of touched on this next question, but what U.S. or non-U.S. businesses have you worked closely with, if you have?
Well, I've worked closely with Boeing, particularly in commercial crew. We've worked with Northrop Grumman in the past. They launch our vehicle, SpaceX, as well. NanoRacks has done a lot of our launch integration activities on the CubeSats. And KBR Wiley down in Houston, we have a couple of our students that are going to be working with them on human factors and spaceflight next year. So,
Okay.
So we also work with CU Aerospace, which is a smaller firm here in Champaign-Urbana. And my research group has done some work with Draper Laboratory, which is a nonprofit R&D lab. Does a lot of guidance and control work in the space program.
So I know there are a lot of companies involved in new space. How do you end up linking up with them? Are they basically contacting you, or do you have some process where you meet up, annual conferences or something?
Well, as a professor of practice here, I started about a year ago coming in from government and industry. I have a lot of connections with those folks from my past. Worked intimately with Blue and Boeing and companies like that. And we have a lot of alumni out in the field working in those companies as well. So we take advantage of those relationships to bring in work. We bring back alumni to review, have design reviews with our students. Those kind of connections.
That was what popped in my head. Is we have a pretty active alumni base, and certainly we are pretty good luck at having alumni from industry, from a variety of different companies come in and serve as judges and things for students. But yeah, I think it's mostly just like it probably has always been, those personal connections are what really do it. I mean, there is the occasional, you run into those people at conferences. I was at the American Geophysical Union meeting a couple weeks ago, and there just happened to be someone from Blue Origin's sort of student launch programs in the audience, and we talked afterwards. So those kind of things do happen. But the connections through alumni and former students, and they get a lot out of it too. I think they are looking for good students in hires, and we can supply them. Those are places students want to go. So,
are there any conferences you'd like to mention that are particularly good for networking opportunities, or there are a lot?
Well, yeah.
It sort of depends. There's a lot. Yeah, there's
Well, one example is the International Astronautics Conference that was just held in D.C. this summer. We actually had a group of students go there presenting a paper on some work they had done developing an EVA tool for handling sharp edges on the external handrails of the space station. They took the tool down to the Neutral Buoyancy Lab in Houston, demonstrated it underwater, wrote a paper about it, demonstrated it, and took first place in the student conference area. So they were able to make connections themselves with people in industry. And one of our students, Katie Carroll, was just named one of the top 20 up-and-coming students by Aviation Week in the space program. So we're pretty excited by that, to have that caliber of students here and getting their careers started early, networking at these conferences.
Okay. What national, state, or other government initiatives have been or may prove useful to your programs or the field in general?
Well, it's a pretty long list. I know on the sort of university spaceflight project side, NASA's CSLI program, which stands for CubeSat Launch Initiative, provides basically no-cost rides to space for university flight projects. Also, the NASA Flight Opportunities Program, which provides launches for high-altitude balloons, sounding rockets, as well as orbital missions, are hugely valuable to us.
The undergraduate science instrument program sponsors a number of our cubesats and the launch opportunities for them.
And I think it's worth mentioning that, you know, some of the larger programs, you know, like Artemis, for instance, that NASA has, you know, we're not going to be building crewed lunar landers here at the university. But those projects do provide some focus and I think a lot of inspiration to our students. So those are of real value to us too. Even if we're not, you know, directly involved, there's no money flowing in those instances.
How about the state? Does the state itself provide any sort of STEM or STEAM kind of support that's helpful to your program?
Well, we are working to expand those opportunities. I would say the university has connections in Chicago, of course, with the Discovery Partners Institute. That's a new effort on behalf of the state to take advantage of the technologies that are being developed here in the university and commercialize them or make them available to the small businesses that might be able to utilize them. So there are those kinds of opportunities. At the space program level, those are sort of the things we're working on today to expand the awareness of what we're doing here and how we can help other businesses in the state with high-tech kinds of items.
Does the school have any educational resources that you'd like to highlight, and that could be maybe software or hardware or laboratories that you have that kind of stand out from other programs?
Well, I'd say the big one is our Laboratory for Advanced Space Systems at Illinois. We call LASSI. LASSI's our CubeSat lab, and it gives an opportunity for students to come in, design, develop, test, and operate CubeSats. That's an opportunity that Zach and I didn't have back when we were going through school, of course. So being able to actually touch flight hardware, see it operate in space is a very unique experience and one we're really proud of here on campus.
Yeah, a new facility for that is actually under construction right now. So we're going to have a nice, big, new lab space with a big clean room and a
state-of-the-art equipment.
Yeah, and a new operations center, more than just a Windows. I think too here at least with the way the University of Illinois is set up in the College of Engineering, I think one of our strengths is just access to all the different engineering disciplines and all the laboratory facilities on campus is really easy. We're pretty centrally organized, you know, so we send students over to use facilities over in electrical and computer engineering. In fact, our antennas and everything for our communications with satellites and things are all over in electrical engineering. Material science labs, all that stuff is available, and I think that's relatively unique.
We're very interdisciplinary because of that, and that brings in a lot of new ideas from other departments in the campus here.
How many students do you have, graduate students?
In the department, we have about 150 graduate students, I think.
Right.
It varies somewhat here and there, and that's about half PhD students, about half master students.
Okay. So you touched on this next question. Does the school have any significant future plans that you'd like to mention in these fields? And you mentioned the new state-of-the-art laboratory. Is there anything else?
Yeah, I think we're continuing to invest in faculty hires in sort of the space systems area. That's ongoing, but that takes time. Yeah, certainly our big addition we're getting on our building is in progress. That should be done
at this time next year.
Yeah, well, definitely by then. Those are probably the two things you can think of.
Yeah, to the extent of the faculty, I think we added 7 faculty to the aerospace department last year. So this is a growing field. We see that in enrollment and admissions, and the university is responding by providing quality faculty to teach the students that are coming in.
And the other thing I mentioned too is we've got 3 university flight projects, satellite missions that are going to launch in the next year and a half.
Right.
And we've got several others in the pipeline behind those. There's going to be a lot of exciting things to do in terms of integration and test and operations for those systems as they start to return data and those sorts of things.
Okay. Yeah, actually, when it does return data, what do you guys have in place? How is that analyzed and processed and all that?
Well, as Zach mentioned, over on the rooftop of an adjacent building, we have our antenna and our receiving systems. They pack that information over here to our labs, where we have computers set up to receive the data that students monitor, track the satellite, downlink the data, and then review it. In our new facility that'll be coming online, we'll have something that looks more like mission control in Houston. Large glass windows that people walking down the hallway can look in to see the operation, several consoles, big screen TVs, just like the big boys. So we're looking forward to having that operational and having student teams taking a hand at operating a satellite.
Wow, that's pretty cool. Now, this is more a sort of a general question, maybe not so much about the university, but do you see any obstacles or challenges in the development of space technology or in STEM education that you'd like to comment on? And this can include funding, legislation, or outreach efforts.
Yeah, you know, the big thing is the stability of government programs is important. Programs that change as they have over the past 2 or 3 administrations, where we're going this place, then that place, then back to this place. It's hard for a student to make a decision or an assessment of what they want to do in their career when they can't see what the forward path looks like. So I hope that Artemis is here to stay, that we have a path forward. I think there's enough inertia developing as we started the conversation with commercial space, that folks like Jeff Bezos and Elon Musk want to go to the moon. So that will probably provide some additional impetus to keep the program on track. But that's really the major obstacle, is just stability and funding of the programs that we're working on that our students will graduate into.
Yeah, and even at a lower level in terms of funding for universities for research, generally funding for spaceflight projects and spaceflight research comes from the federal government, and generally it comes from NASA. The National Science Foundation tends not to invest in that area because they see NASA, and I guess the U.S. Air Force also invest in that area. And NASA can be pretty inconsistent in terms of funding programs and vehicles. For instance, we had several of our CubeSats were funded through the NASA University Student Instrument Program. That was maybe 3.5 years ago. We've heard there's going to be another opportunity for that coming out, but nobody knows when or if or what it'll look like. Like I said, it's been years now, and that's I think pretty consistent with NASA's university and research funding initiatives. They're kind of all over the place sometimes. There's not a lot of predictability there, which is unfortunate, but you know, we do what we can. You know, on the STEM education side, you know, we have persistent issues with trying to address systemic imbalances in terms of getting more women into the field and other underrepresented minorities. And it's a challenge. You know, there's an element of sometimes, you know, we're fighting our peer institutions for the same small batch of people, aspect, as well as the other of, you know, putting resources in to try and grow the pie so that there are, you know, that more people are interested and want to get into this field so we can take advantage of all those skill sets that we're not leveraging right now. And that's a really hard problem. I don't know that anybody really knows the answer. So, you know, since I've been in academia, I feel more and more that maybe the central challenge is that's something that really has to be addressed sort of globally across all educational levels. Trying to coordinate, you know, everything from, you know, grade school up through university and graduate education, including industry, is a real challenge.
How does it break down your student body at the graduate level, U.S. versus non-U.S. students?
Yeah, I don't know the answer to that.
Yeah, and we're predominantly domestic. I know the majority of students are domestic, but I don't know what the actual split is. 80-20-ish, I think.
Okay.
The challenge for foreign students is we get a lot of great foreign applicants, but it's expensive for them to come here. But also, you know, they come here and they get a degree. You know, if they don't have a green card or a citizenship, in which case they remain foreign, it's almost impossible for them to get a job in the United States in aerospace because of export control regulations through EAR and ITAR.
Yeah, in fact, our graduate advisor was expressing a concern to me this week about students going home for Christmas break and can they get back into the country? That's become a concern now, so we need some stability in that area.
Yeah, and I think we have to turn away, at least I have, and not considered, people who are probably excellent students, and would be great additions, in my opinion, to the U.S. workforce, because a lot of that, and I think it's gotten worse in recent years in terms of people's being able to get access and waivers for those kinds of things.
Interesting. So, what excites each of you about this field?
For me, I've got an old saying that scientists discover what is, but engineers create what never was. So being able to develop something new, original, never been done before, and to now work with students that have no preconceived notions about anything. So they're not held with my, umpteen years of bias. To see them innovate, come up with new ways of getting around old problems, that's pretty exciting.
Yeah, I spent some time in industry before coming back to academia. You spent a lot of years in industry. Aerospace has a reputation for being kind of boom bust, and it's probably deserved, more or less, 80% of that. You get used to program cancellations and things, very disappointing. But you move on and you get used to it. But being here at the university, being exposed continually to students and their enthusiasm and just the amount of stuff that they can do, it's inspiring, like every day. It's really fun to be around that energy and to be able to use it to solve new problems and things. And we've been talking about commercialization. There's things I think people have been thinking about for years and years and years in aerospace, and people are doing it now. These small companies are just doing it. Stop thinking and just go do it, and it's amazing. And that there's this great feedback loop with the students, and they're excited, we're getting more, and they're doing even cooler things, and I have no doubt that they're going to go off and continue this trend, I think, which is great. I don't know, I've been interested in space exploration and aerospace since I can remember, since I was a little kid.
Yeah.
I was a nerdy little kid, admittedly, but that part of me still gets goosebumps when I see SpaceX, land a first stage, or hear about, companies building, CST-100. Their test flight didn't go perfect today, but still, amazing accomplishments. The things that are maybe going to happen with, what's the commercial lunar lander?
Yeah, the CLIPS program.
That's amazing. The fact that at university level that we could maybe send a payload to the surface of the moon. That's insane. It's amazing. So it's an exciting time, and I think I'm hopeful, and I think not unrealistically so, that it's going to continue.
So a couple tech questions, just tangential. So one for each of you. Do you think it's best to go to the moon next, or just go straight to Mars? And the second question is, how do you approach space debris in low Earth orbit when you deal with CubeSat stuff?
Well, I think we have a couple of issues that we have to address. One of them is the aging space workforce within NASA. The median age at JSC is in their 50s. We have to, a lot of the Apollo era knowledge is walking out the door, if you will.
It's gone.
Or gone, as Zach said. So we need to redevelop a lot of that, and it's a lot easier to do that 3 days away than 6 months away. Space is an ocean, and you're not going to cross the ocean in a rowboat. So we have some work to do in developing technologies before we can get to Mars. And that's one of the exciting things of being here at the university, is seeing some students come up with new concepts on how to get there faster with less radiation damage and other problems that astronauts will face. So clearly, I think the moon is a stepping stone. We need to redevelop those capabilities and that technology and the systems. And space station improves that too. I mean, we have a hard time keeping the logistics train just 62 miles away. And so we need to develop all of those capabilities as well.
I'm going to give you a slightly different answer to that one. People spend entirely too much time arguing about it and not enough time doing it. The moon is a good stepping stone. A lot of the technology you need to develop would be very consistent between the two. But there's a fair-sized set of technologies that you need on Mars that you don't need at the moon. And so then and there's a smaller set of technologies that you need at the moon that you don't need at Mars. In terms of system development, things you have to pay for. I think it's important that we're doing something and doing it consistently. Partially for workforce development, right? If you look at, say, the Mars exploration program, the robotic program has been very successful because they have maintained a cadence of mission after mission to build up that capability and that workforce and do a few new things each time. And all of a sudden you've got really capable, nuclear-powered rover running around Mars, opposed to, landing it on airbags like we were doing in the 90s. I think, that's a hard thing to do from NASA's perspective. They're beholden to the whims of whatever administration comes in. But I think it's more important that we just continue to do something. And if we end up feeling that it's time to put the money into the lunar lander and go to the moon, great. If we want to put that money towards building, longer duration in-space HABs and entry, descent, and landing technology for Mars, sure. But let's just do one of them and not get into these food fights about which one's more important or not.
Mm-hmm. And the low Earth orbit question about space debris?
Well, it is going to be an issue. We had a talk the other day in our senior design class about the ethics of launching constellations of 30 or 40,000 satellites, taking away night sky views from future generations, because the sky will be abuzz with moving lights. And all of that debris is going to eventually have to come down. We're working on a couple of technologies here at Illinois for dealing with those issues, create additional drag or to bring it out of orbit on an earlier basis. So it's going to certainly be a challenge. It's a fun, I'll say, problem to deal with, and
it's technically interesting.
It's definitely
it'd be nice if we didn't have an issue as a problem. Yeah, and I think the thing about low Earth orbit is nothing in low Earth orbit is probably still going to be there in 20 years. It's all going to come down. There's enough drag, there's enough atmosphere, not very much, but enough that those things will come down. Some of the higher altitude orbits in the long term may actually be more problematic in terms of decluttering them. But it is an issue. I think, like you mentioned, it's not university CubeSats, quite frankly, that are going to be the problem, although there's been some worry about that, say over the past 10 years. There were going to be these mega constellations. And with that many vehicles, and if you launch 10,000 satellites and 1% of them are duds or don't work, that's 100 pieces of debris. But you have, you're tripling or quadrupling or multiplying by 10 the number of things we have in our low Earth orbit. So collision risks and all the things are much higher. Probably not a doomsday scenario, but it could be a mess.
Right. Yeah. Yeah, it's fascinating stuff, definitely. All right, that's all the questions I have. Do you guys have any final thoughts or words on the study of space technology or your school's programs?
Well, I think it's just a great time to be an undergraduate here, to be able to put your hands on to spaceflight hardware, to operate it, get that experience, and then carry that out to industry with you. I think we're preparing some really good candidates for the future programs, and it's going to be exciting to watch them grow and prosper out in the real world.
Yeah, I'd just say if there's students or high schoolers that that are interested in space technology, just to tell them to go for it. When I was an undergrad studying aerospace, I was convinced that, I liked airplanes too, but spacecraft was what I really wanted to do most, but I had convinced myself that there weren't any jobs in spacecraft. Granted, this was years ago. And I was going to go do airplanes, which was definitely my second choice. I had one internship at an aerospace company out in Colorado, and if it hadn't been for that, I'd be in a very different place. That totally changed my mind about working on satellites and things. And basically, I did like a left turn my senior year of undergrad. And I think particularly in this time, with the things that are going on, maybe students wouldn't have that view anyways, but to just go for it. You'll find it. It is there.
Cool. All right. Well, thanks for speaking with me.
Sure, Chris. Good to meet you.
Thanks for the opportunity today.
Thank you for listening. You can find more podcasts like this on your favorite podcast feed under the title Spacewalk's Money Talks. That includes Apple Podcasts, Stitcher, and Spotify. One great way to support me is to rate my podcasts, either good or bad. You can find more fascinating information at spacewalksmoneytalks.com, on YouTube under Spacewalks Money Talks, on Facebook under Spacewalks Money Talks, on Instagram under Spacewalks Money Talks, and on Twitter at SpacewalksMT. Don't forget to sign up for my weekly newsletter where I recommend newly published books. The subscription box is on my webpage. Thank you for listening.